The first thing I'm going to do is to install the Mediator NuGet package. So let me search for Mediator, and I'm going to install the Mediator NuGet package. Then I'm going to add a new class at the root of the application project, and I'm going to call this class dependency injection. This is going to be a static class, and it's going to be responsible for registering the services that are specific to the application layer. We're going to do this by defining a public static method, returning an instance of the iService collection interface, which is what we use for configuring dependency injection in .NET. I'm going to call this method add_application to be specific that this is introducing application-specific services, and we're going to make it an extension method of the iService collection interface. Let's also return the services right away and see what we're going to place inside of the body of the add_application method. I'm going to start by registering the Mediator services, and I need to call the add_mediator method, which is available from the Mediator NuGet package. It accepts an action on the Mediator service configuration, and we're going to use this Mediator service configuration instance to configure the required services for Mediator. Mainly, this is going to be wiring up the command and command handlers and the query and query handlers. To achieve this, we're going to say configuration, and we're going to call register services from assembly, and then we're going to give it an assembly instance. I'm going to say type of dependency injection, and I'm going to get the assembly of this type, which is consequently going to be the application project. This is everything I need to configure Mediator at this point. I'm also going to configure one more service, and I'm going to say add transient, and I'll specify the pricing service, which is currently in the domain project. So I'm going to go ahead and add a project reference to the domain project. Now I should have access to the pricing service because it's public, and I can import it with an appropriate using statement. We're going to be calling this method later on in the course from the API project to configure all of the services for the application project itself. Now let's see how we're going to implement CQRS. I'm going to start implementing CQRS by defining a new folder in the application project. I'm going to call this folder abstractions, and I'm going to add another folder right under the abstractions folder, which I will call messaging. Inside of this folder, I'm going to define my command and query abstractions. So let's start by defining the iQuery interface. I'm going to make this interface generic with a tResponse argument. tResponse should specify what is the type returned by this query. We're going to leverage Mediator to implement our iQuery interface, and we're going to implement the iRequest generic interface, but I'm going to use the result object from our domain layer, and I'm going to use the generic variant, which is going to accept the tResponse coming from my query. Essentially, my query is going to be a Mediator request returning a result of tResponse object. I want to enforce that all of my queries in the application return an envelope response, which is the result type. The queries can either succeed or fail, and the result object should communicate this. I'm also going to define a respective iQuery handler interface. So let's go ahead and create that one. This interface is also going to be generic, and is going to have two generic arguments, the query and the response type, and it's going to implement iRequest handler coming from Mediator. I'm going to pass the generic arguments on the query handler to the request handler, and I'm also going to specify an envelope response for the result object. So we're going to return a result of tResponse. And I'm also going to define a generic constraint that my tQuery generic argument needs to be an iQuery of tResponse. Now we have the query and query handler abstractions. Let's do the same for the command and command handlers. I'll start by defining an abstraction for our iCommand. The first kind of command that I want to define is one that doesn't return any result. So I'm just going to implement iRequest and return a result object from this request. Then I'm going to define one more command interface. This one is going to be generic, and it's going to return some sort of generic response. and I'm also going to be returning a result of tResponse respectively. The idea behind these two interfaces is similar with the iQuery interface. We want to enforce that all of our commands have to return a result, and we also allow the flexibility for the command to return some sort of value which could be useful in some use cases. I'm also going to add one more interface, which is going to be the iBaseCommand interface, and I'll have both of my command interfaces implement the iBaseCommand interface. The value behind having a base command interface is that we can apply generic constraints in our pipeline behaviors, and you'll see why this is useful when we implement our cross-cutting concerns later in this chapter. Now we need to define the command handlers for these two command types. So let's go ahead and add another interface. This is the iCommand handler. I'm going to add the implementation for the command which only returns a result, and I'm also going to add the implementation for the command handler interface which accepts the command that can return a response. So now we have our abstractions that we need for CQRS, and let's see how we're going to use them. I'm going to start by adding a feature folder in the application project, and it's going to hold the commands and queries for this specific feature. So I'm going to create a top-level folder for our bookings. Inside of this folder, we are going to be defining any features related to bookings, which could be commands or queries. Let's define our first feature, which is going to be the reserve booking feature. I created the respective folder, and inside of it, we're going to define our reserve booking command. I'm going to add a type, which is going to hold my reserve booking command. I prefer using records and the primary constructor feature for defining my commands. For this to be a command, we need to implement the iCommand interface. I'm going to implement the generic variant, which returns a GUID, which is going to represent the ID of the newly created booking. We also need to provide the data that is required to handle this command accordingly. So let me add that. We're going to need the apartment and user identifiers and the start and end date of our booking. With this in place, let's go ahead and implement our command handler. I'm going to add another class inside of the reserve booking folder, and this is going to be the reserve booking command handler. I prefer making my command handlers internal and sealed, and we also need to implement the iCommand handler interface. I need to specify what is the command that I'm handling. In this case, that is going to be the reserved booking command, and this command returns a GUID response, so we need to specify that. Now we can implement this interface, and we need to implement the logic for handling this command in the handle method. You can see how this promotes the single responsibility principle, because the reserved booking command handler is only responsible for handling one command. Now, what do we need to handle the reserve booking command? I'm going to start by injecting some interfaces. So first, we're going to need the user repository, which I have defined in my domain layer. Then I'm going to define a field for the iApartment repository. Then I'm going to need the iBooking repository to add this booking if we manage to reserve it. I'm also going to need the iUnitOfWork to persist all of these changes in the database, and then I'm going to need my pricing domain service. So I'm also going to inject that. So pricing service, all right. If I'm missing something at the moment, we're going to add it later. Let's go ahead and generate the constructor. I'm going to align these vertically so that you can see clearly what are the constructor arguments. So we have the user, apartment, and booking repositories. Then we have our unit of work. And lastly, we have the pricing service, which is a domain service. Now we can go ahead and implement the handle method one step at a time. The first step is going to be to fetch the user by the identifier. We're going to call the user repository, give it the user ID, and get back a user. This could be null, so we're doing a null check. And in case the user is null, we're going to return a failure result by passing in the user errors not found as the failure reason. Then we're going to fetch the apartment entity from the database. We'll use the same approach where we access the repository, get the apartment by the ID, and perform a null check. If the apartment is null, we return a respective failure result. The next step is going to be to create our date range value object. It encapsulates the start and end date of this booking, and if I take a look at the create method, you'll see that it's going to throw an exception if we try to create an invalid date range. We're going to introduce validation later on to make sure that an invalid command never reaches the command handler, so there's no fear of actually throwing an exception with this call. We're just adding it as a guard clause in the value object, but we don't expect to throw the exception in a normal application flow. Then we need to check if the booking that we are trying to reserve is overlapping with an existing booking. This is an optimistic check to the database for this apartment and this duration. It's going to check the booking table to see if somebody else managed to reserve this booking before us. So if that was the case, unfortunately we have an overlap and we have to return a respective failure. The next step is going to be creating the booking by calling the booking reserve method. We're passing in the apartment, the user identifier, the duration of the booking. I'm also passing in UTC now and the pricing service to this method. Then we are going to add the booking to the repository, and we're also going to call the unit of work save changes method to persist all of the changes to the database. Lastly, if the save changes method succeeds, we can return the booking ID from this method. One thing I want to address is having to use datetime UTC now as part of our command handler. A much better solution would be to define an abstraction that we're going to use to get the current time. So let's go ahead and do that. I'm going to create a folder inside of the abstractions folder, and I'm going to call this folder clock. Inside of this folder, I'm going to add an interface, which I will call iDateTimeProvider, and this interface is going to return a datetime property, which is going to be called UTC now, and it's only going to have a get method. Now we can use this interface inside of our command handler. Let's go back to the command handler. So right here, I'm going to define my field, which is going to hold the datetime-provider interface. I'm going to inject this field from the constructor, and at runtime, we're going to get an implementation of the datetime-provider interface. Now we can use this interface when we are passing the UTC now to the reserve method, and we can say datetime-provider UTC now. The benefit of this approach is that this is completely testable. If you can't reliably test your code that is working with a datetime object, then you risk introducing many potential bugs, and this approach using a datetime provider abstraction solves that because you can easily mock it and provide the date and time value that you need to satisfy the test. Let's take a high-level view of the handle method and do a short review of what's going on inside. So we are fetching the user entity using the repository. Then we are fetching the apartment, creating the date range value object, performing an optimistic check on the database to see if we are overlapping for this apartment's booking. If the previous check succeeds, we are reserving the booking, adding it to the repository, and persisting the changes to the database. If you have a little bit more experience, you might raise an eyebrow here and ask yourself, did we just introduce a race condition? The short answer is yes, and I did it on purpose. We're going to solve the race condition that we have here later on in the course by introducing optimistic concurrency. But first, let me briefly explain what the issue is here. So we are performing an optimistic check on the database to see if we have an overlap for this apartment and duration. If this check succeeds and we get back the information that there is no overlap, then we go ahead and create our booking and try to persist it in the database. The problem is that we could have two separate transactions, both trying to persist the booking after succeeding on this check. There are two ways to solve this: pessimistic or optimistic locking. Pessimistic locking means creating a transaction with some of the more constrictive isolation levels. Optimistic locking means that you have a concurrency token present on your entities, and actually this is the approach that we are going to take. The reason for using optimistic locking is that it's more performant and it doesn't require locking a certain number of rows in the database for an extended period of time. but we're going to dive into the implementation details of that later on in the course.